So today, Shabab, inshallah, we will continue our discussions on single-phase induction motor. As you remember, previous classes, we discussed the construction of the single-phase induction motor, the theory of the double rotating field, and we recognize the problem of induction motor starting, why a single-phase induction motor is not a self-start motor. It needs something to make a component for starting torque or flux in the beginning. Then we discussed the different circuits used to start the induction motor, and we agreed together, Shabab, that each motor has a name with the same of the starting method. So we had four starting or five starting methods. Each method with a name is the same of the motor name. For instance, we have the name of shaded Boole method, so the name of the motor is shaded Boole induction motor. We have a name of capacitor start, so we have capacitor start induction motor, and so on. Today, inshallah, we will continue our discussions in the equivalent circuit of single-phase induction motor, and this will include the equivalent circuit at steady state. So, at steady state, Shabab, we will care about the equivalent circuit of the motor, including main winding and auxiliary windings, or the split phase induction motor. So, which means both of a forward flux and backward flux will be there. Okay, Shabab. Sorry, again, we will consider the operation at steady state, which means we have main winding for forward and backward flux. So the auxiliary winding will be out of the circuit. So this equivalent circuit, Shabab, that we are going to discuss, inshallah, can be used for capacitor start. Because for capacitor start, the capacitor will be removed from the circuit after starting. It can be used also for, let's go to the different types. We discussed it here. So for this technique, split phase motors, it can be used because the switch will be disconnected after 75% of synchronous speed. So finally, we'll have main winding, and we are going to discuss the effect of main winding in the equivalent circuit. So this type is valid for the model we are going to discuss. Capacitor start is the same because the capacitor along with the auxiliary winding will be removed at steady state. However, capacitor run are not valid for the model we are going to discuss today. Okay, Shabab, because for capacitor run, you have both of windings along with capacitor. So the model, what we are going to discuss it, inshallah, in our course, cannot be used for this type of motor, capacitor run. Also, this type of motor, this is here capacitor run, and it started with capacitor start as well. So it's the name of the motor is capacitor start, capacitor run, and we are not going to include this in our mathematical model. So the model we are going to discuss cannot be used for this type of motors. There will be some differences, Shabab, due to the extra inductance and the capacitance in the circuit. Shaded Boole can be made in different simple model, okay? Because the as you can see, it's similar to capacitor run. صح يا شباب? So it's different a bit also to our model that we are going to discuss, because these windings are inserted for all of the operation during starting and steady state. So the model what we are going to discuss, Shabab, is just for the single phase induction motor when the auxiliary windings are removed. Okay, so this is our model what we are going to discuss, inshallah. Now let's start the analysis and equivalent circuit of this type of motor. Firstly, Shabab, if we have the rotor equivalent circuit, for induction motor, we have stator and rotor. Stator circuit and rotor circuit. For the rotor circuit, assume that firstly we have EF, which is the excitation voltage on, or the reflected voltage on the rotor, okay, the EMF on the rotor circuit, and it will be applied to the rotor circuit, which is already short circuit, شباب, X2 and R2 over S. So this is now the effect of the normal circuit. However, this is due to the forward flux, شباب. So this is now similar to three-phase induction motor, which has only one component of flux. Three-phase induction motor has only forward flux. صح يا شباب? This is what we have already concluded from the derivation of the three-phase magnetomotive force. The flux was sinusoidal, and all of backward flux were cancelled. So the forward flux effect on the equivalent circuit will be the same as three-phase induction motor. So this is now the equivalent circuit due to the part of forward flux. But what about the other part, the backward flux? Backward flux, the motor will rotate in the opposite direction of the synchronous speed of that flux, of backward flux. So we can say now SB equals NS minus NR, because the rotating flux in the backward direction will see the motor is moving in the opposite direction. This is right, which means it will be higher than the value of slip given before for the three-phase induction motor, because the backward flux is moving in a speed of ns, and the motor is moving in the opposite direction because it's moving already with the forward flux. So the speed will be minus nr over ns, which means finally the value of slip for the backward component will be ns plus nr over ns, which is nothing but 2 minus ns. Sorry, 2 minus s. So the forward flux has a slip equals to the forward slip for the other configurations for the three-phase. However, the backward flux will have a slip equals to 2 minus s. In this case, you can just represent the equivalent circuit by the same way. So the backward equivalent circuit can be x2 and r2 over s backward, which is 2 minus s. So this is now considered as the backward rotor equivalent circuit. So this is, شباب, the two components of rotor. What about stator, شباب? Is the stator going to be affected by the forward or backward flux? Or just rotor? Huh? شباب, what do you think? Who can answer me, شباب? What do you think? Now the flux is moving from stator to rotor, is it right? The flux is made by the stator and it will move to the rotor circuit.
Yes.
So it's expected only rotor circuit to be affected by forward and backward flux. Is it right?
Yeah, exactly.
Fine. For that, the overall equivalent circuit of a single phase induction motor will be like that, شباب. We have a stator equivalent circuit, which is R1 and X1. And then we will have the other part of the rotor circuit. طبعا you have the magnetization reactance, X magnetization, over 2, because one half will be affected by the forward and the other half will be affected by the backward. So here we have EF forward due to the forward flux, due to that circuit we already discussed here. This is EF forward, okay, and here EB, which is a backward EMF. So we will have the part of forward flux here. This is XM over 2. This is 0.5 X2 prime. طبعا all prime, شباب, because we refer the values from rotor side to stator side. And here also 0.5 R2 prime over S. Why S? Because this is forward. Because S forward equals S of motor, which is NS minus NR over NS. For the part of the backward impedance, So we will have firstly the part of magnetization xm over 2 and 0.5 x2 prime in series with 0.5 r2 prime over 2 minus s. Here it's 2 minus s because it's backward flux. We can simplify the circuit يا شباب. طبعا here we have two series elements in parallel with another element. So the combination will be this impedance multiplied by that impedance divided by the summation of the two impedances. So we can call this part here as Z forward. So Z forward equals, as you can see, J.5 xm, this part, which is in parallel with this branch. So it will be multiplied by this branch, which is minus J.5 x2 prime plus 0.5 r2 prime over s. Then in the denominator, the summation of the two branches impedance. After you get the value of this impedance, we can give a name for the real part as RF, which means equivalent forward resistance, because there is no physical element in the motor called forward resistance. This is just equivalent. And also equivalent forward reactance. And we can make it like that. It's just one impedance, XF and RF. So we just simplify the circuit here to that circuit. So this is now, this part is called Z forward. Similarly, we can make the same for the backward impedance part, and we give it a name of X backward and R backward. And again, this is not physical impedance or physical resistance or inductance. This is just equivalent, because physically the motor has only squirrel cage and one winding on the stator. Okay, شباب? Is it clear يا شباب?
Yes.
طيب جميل. Now طبعا regarding the parameter names يا شباب, يعني as you know from the beginning, it's similar to three-phase induction motor. So R1 is the resistance of the stator winding, X1 is the leakage reactance of stator winding. All of time we refer one to the stator side. Okay, Xm or Xmag is the magnetization reactance. X2 prime is the leakage reactance of the rotor, reflected or referred to stator side. R2 prime is the resistance of rotor, referred to stator side. V1, this voltage is the supply voltage. EF is the forward flux, which is equals 4.44 multiplied by frequency, multiplied by number of turns per phase, multiplied by forward flux peak value. Here, for EB, backward EMF, equals the same, but only the difference in backward flux also. Okay. So this is now, Shabab, the equivalent circuit of single-phase induction motor. Now, we need to understand.
Yes. This is the equivalent circuit for the 75%, right?
This is the equivalent circuit at steady state.
Okay, yeah. So after
it's include only the part of main winding now, without any auxiliary windings.
Yes. Okay.
Okay. So we cannot apply this circuit for starting. It's just applied for steady state.
Yes. Okay.
Regarding the power flow, you know that previously for three-phase induction motor, we said that the gap power equals the power which is already transferred from the stator side to rotor side, which will lose some copper loss on rotor side. Then the remainder of power will be the mechanical power, which will be converted to the output power after losing some friction loss. So this is now the concept of power transfer from stator to rotor. Now we have two fluxes, so it's expected also to classify the power into two parts. One part due to forward flux and another part due to backward flux. But let's define these relations in terms of the final equivalent circuit we have it here. Okay, شباب? So firstly, if you would like to make any analysis in power flow, you have first to obtain the value of ZF and ZB. This is number one. First thing you have to make is to get the equivalent circuits here. Fine. So we said that the gap power will be divided into two parts. One part will be B gap forward, which is nothing but the power in forward direction or forward flux direction moved to the rotor circuit. طب now يا شباب, let's go to the equivalent circuit again. طبعا this part now representing stator. All parts here representing stator. And the right part here represent rotor. So the gap power which is going to be here can be represented in terms of RF and RB. So we will have part of power as forward power, which will be applied to R forward. The same is also for backward power, which will be applied to R backward. Like, what will be the current, شباب, now? Is it going to be different between backward and forward? Or we have only one current now in series for all of impedances, which is I1?
Yes, the same current.
Just one current, صح?
Yes.
So we can say now, شباب, B gap forward equals I1 square RF. Like, what is I1 here, شباب, line or phase? Just to check if you are following or not. I1 شباب. Why not line?
It's a single phase.
It's single phase. There is nothing here called line or phase. صح? The connection is only one phase. There is no star or Y connection or delta connection. So this is one current, شباب. So for this type of problems, when you have V given, you shouldn't divide over square root of 3 because it's single phase. Is it right? Right. So now we can say that we have B gap forward I1 square RF and B gap backward I1 square RB. And the component of torque for each part will be T forward and T backward, which is nothing but B gap over omega. Omega here, which is a synchronous speed, not the rotor speed, because this is electrical torque. So T forward is B gap forward over synchronous speed, and T backward equals B gap backward over synchronous speed. Now, will the machine start moving as a function of summation of the two fluxes or the difference between the two fluxes, شباب? We said that forward flux and backward flux are moving in opposite directions. So it's expected that the machine will move with the difference between the two fluxes. Is it right? So now we can say torque, which is the effective torque that will move the machine, will be the difference between forward and backward. So this now represents the resultant torque, which we said that this resultant torque at starting equals 0, because forward and backward flux at starting equals the summation of them equals 0. صح يا شباب? So here the torque or effective torque or resultant torque equals T forward minus T backward, which means if you use these relations, it will be I square over synchronous speed multiplied by RF minus RB. So from here, we can say now the mechanical power equals this electrical torque multiplied by omega m. And you know omega m equals omega synchronous multiplied by 1 minus s, which can be equivalent to, you know, in three-phase induction motor, P mechanical equals 1 minus s multiplied by B gap. Right. This is 1 minus s, and this is already B gap resultant value or difference, which depend on the difference in torque. So we can say now I1 square multiplied by RF minus RB multiplied by 1 minus S, which is nothing but B gap forward minus B gap backward multiplied by 1 minus S. So take care, when you calculate the power consumption from the stator side, you should add all of power. So if I asked you how much power will be transmitted from stator to rotor, you should calculate the summation of B gap forward and backward. However, what is the effective power that will affect the motor motion? It should be the difference between them. Is it clear يا شباب? Huh? This part, is it clear?
Yes.
So again, the motor will move with the difference between B gap forward and backward. However, the overall power which will be absorbed from the supply should include the summation of this power. So this is now the difference شباب in power calculation and power flow. طبعا finally the output power of the motor equals P mechanical minus P rotational. طب now if I would like to calculate input power of the motor يا شباب, what will be the different powers we should add together? So we can say B input equals, who can say شباب?
Maybe Dr. Kabar.
We have B cover on stator, so we can say B cover 1 plus
We develop
cover 2.
يعني instead of going in details in B cover 2 and all of this, we can say the summation of gap power, because the gap power will include all of power that are going to be used in the rotor and output as well. Is it right?
Yes.
يعني we can say now plus B gap forward plus B gap backward. صح كده يا شباب؟ However, in terms of output power, we can say P out equals B gap forward minus B gap backward multiplied by 1 minus S. This now will represent mechanical power, then minus B friction. صح كده يا شباب? Is it clear? So this now represents the motor output power. طبعا يا شباب, due to يعني the numerical analysis here, and we can see that يعني B gap is subtracted here, so we expect to have lower output power if we convert the numbers with the three-phase induction motor. For that, you will find the efficiency of single-phase induction motor يعني is small compared to three-phase induction motor, and we will see this inshallah in exam. So if you would like to calculate the copper loss due to forward flux, it will be B2 forward, which is S B gap forward, which is equal to I1 multiplied by R forward, I1 squared طبعا, صح? Multiplied by R forward. This is now representing the copper loss of forward flux. Also, the same for the A backward flux. B2 backward, it's 2 minus S multiplied by B gap, which will be similar to I1 square multiplied by R backward. طبعا يعني this is the same relation. B2 copper loss, if we would like to obtain the overall copper loss, طبعا you should add the forward and backward flux, and this is يعني nothing but I1 square multiplied by R forward plus R backward. And as we said, the gap power we can use in order to obtain the input power, it should be summation of the two terms. And this is our relation for input power as it is. طبعا يعني you have to take care that طبعا the input power equals V terminal I1 multiplied by power factor, and power factor is nothing but cosine theta V minus theta I. Now let's solve an example شباب to understand the operation and the analysis in our motor. The following test data are obtained from 1 quarter horsepower, single phase, 120 volt, 60 hertz, 1730 RPM induction motor. Stator winding equals 2.9 ohms. So this is now the value of R1. We have two tests, شباب. You know, in recent courses, E360, you learn the two tests called the blocked rotor test and no load test. These tests are used mainly to obtain the parameter of the single phase, the three-phase induction motor. The same, this can be also done here for this type of motor. So we have two different tests. One is called the blocked rotor test, which we test the rotor or the machine when we supply it by small value of volt and lock the rotor in order to not allowing the rotor to move. For that, the current will be high. So here, I blocked rotor equals 5 ampere, even if the volt is 43 volt, and it's written here, the motor volt is 120. طيب يعني إن شاء الله شباب, we can discuss this example in more details inshallah next class. Now please, because we have a quiz today, so I will stop at that point now, and all of you please prepare your workplace, prepare your camera, open your blackboard and refresh the page in order to start the exam. يلا تفضلوا شباب.